This video is from Mrs. Cucci's College Now Precalculus class. We are on lesson 4.4, Properties of Logs. We left off on page 1.19, so please go ahead and navigate your way there, and we'll get started. Okay, so we're going to do something a little bit different now. What we're going to do is we're going to learn how to evaluate logs given a specific value. Okay, so we've got, given that log base A of 2 equals approximately 0.301 and log base A of 3 is approximately 0.477, we want to find log base A of 6. So we're going to take a few minutes to kind of go through that process. Okay, so what we're going to do is we're going to take a look at how we can possibly get this value of 6 given what we have. Okay, so what I can do is I can look and say, okay, I have a 2 and a 3. If I were to multiply those together, I would get a 6. So I'm going to rewrite this as log base A of 2 times 3. Now in the last video, we talked about expanding products. And that's what we're going to do, because essentially what we're looking to get is log base A of 2, because we have what it's equivalent to, and log base A of 3. So we're going to go ahead and expand that out. And once I have that, because I know what each one of these is equal to, I can replace these. And then find the sum, which is about 0.778. Okay, so essentially what we're looking to do is adjust what I have here with what I'm given. All right, so the next one we're going to try is log base A of 2 divided by 3. And luckily, that one looks pretty easy. We've got log base 2 and we've got log base 3. So what we want to do is we want to expand this out. We know division becomes subtraction. And then we can replace our values with our values. All right, let's try another. Log base A of 81. All right, so this one's a little bit different. I need to figure out how I can get 81 from what I have here. So remember, we can use multiplication, we can use exponents, we can use division, whatever we need to do to get it. So if I think about 81, I know that I can write 81 with a base of 3. 3 to the 4th power is 81. So, from our rules from yesterday, we know exponents are going to come up front. And then we can replace our log base A of 3 and then multiply. To get our product. Okay. Let's try another. Log base A of 1 divided by 4. Alright, so we want to somehow figure out what to use. Let's go ahead and expand it first. So we have 1. Well, the only way that I can think of to get 1 is knowing that anything to the 0 power is 1. So let's say I write it as log base A of 2 to the 0 minus. Now 4 I can get by squaring 2. Log base A of 2 squared. Go ahead and move my exponents. We know 0 times anything is 0. And then 2 times log of 2. We're going to replace that log base A of 2 with what it's equivalent with. And then find the product. Okay, given that log base A of 2 is approximately 0.301, log base A of 3 is approximately 0.477, find the following if possible. Log base A of 5. All right, so we need to try and figure out, is there something that we can do? Is there some way that I can break this 5 up that will allow us to use this log base A of 2 and log base A of 3? And for this one, there isn't. Log base A of 5 can't be found using these properties and the information given. So this is not possible. And occasionally you will run into something like that. Okay, log base A of 3 divided by log base A of 2. And lucky for us, this is the exact value, so all we're going to do is use our substitution. And this comes out to be approximately 1.585. Okay, so I hope that made things clearer for you guys. Let's move on to the next type of problem. Okay, so now we're going to move on to simplifying expressions of the type log base A of a to the x and a raised to the log base A of x. Now, the logarithm of a base to a power says that for any base A and for any real number x, if I have log base A of a to the x, it simply equals x. It equals the exponent, okay? The log base A of a to the power is the power. So if I want to try log base A of a to the 8, essentially what this allows us to do is if I have this exponent here, we know that that can go out front. All right. Log base A of a to the what power would equal a? A to the what power would equal a? And we know that that's going to be a power of 1. So this piece right here is 1. And 8 times 1 is simply 8. That's how we're able to get this value. So without doing all of this work, we could simply say log base A of a, that goes, I'm left with the 8. Okay, simplify the following. Ln of e minus t to the negative t. Ln e to the negative t. Okay? Remember, the base to the natural log is e. We just don't write it. So this is essentially the same thing. We've got ln of e to e of e, that goes, and I'm left with negative t. Log 10, 3k, raised to 3k, log of 10 to 3k. And this is a common log. So the base here is 10, we just don't write it. So again, it's equal to 3k. All right, so now let's go in the opposite direction. If we're given a base of a raised to the log base a of x, if the base to the exponential function and the base of the logarithm are the same. We're simply left with what's inside the log. So we've got 4 log base 4 of k. Since these two values are the same here and here, this is simply going to equal k. Same thing here. Remember, the base of a natural log is e. So e raised to the ln of 5 is simply going to be 5. 10 log of 7t. Remember, this is a common log, which means its base is 10. It's just not written. So we're going to be left with 7t. Okay, so make sure that if you had any questions, you mark down the time of the video that you were confused on, and we will go over any questions that you have tomorrow. And I will see you then. Thanks, guys.